Hey, welcome to another episode of Tech Talk with Eric. Today is episode 2. We're going to talk about Python directory structures, and we're going to talk about some unit tests as well. We're going to do look at some standard directory structure sort of patterns. We're going to look at setting up our unit test. We're going to look at referencing our modules. We're going to see what happens when that kind of fails and that module not found error that you may get. And I'm not referring to the module not found error that you would get when you install a package. I'm referring to the module not found when it can't find your own internal modules or Python files that you're trying to reference. And then from there, we'll look at using unit tests to debug our application code. So rather than setting up some sort of different entry point to try and test or walk through our code, we can use unit tests for that. It's a perfect use case for our unit test to actually walk through and debug our code. It serves as a kind of a dual purpose for us. Before we begin, I just want to kind of go over really quickly what my directory structure is going to look like. I'm going to keep it fairly simple, fairly basic. I'm going to have a source directory. I'm going to have a test directory. Within my source directory, I'm going to have 3 main directories that I use. I'm going to have a common area for common functions. I'm going to have a models area that represents a model or an item or of a state of something. As you can see, I'm a big fan of Marvel, so I'm going to have a little fun with this, and we're going to pretend like we're an intern at Stark Industries. And Tony has asked us to kind of do a little bit of an overhaul or review of the code that is used for the Avengers and for doing Jarvis's AI security. So we're going to take a look at a model that's an Avenger. We're going to look at a service that is the Jarvis AI security service and how that service uses a model which loads an Avenger. So it would load like Tony Stark or load Thor, and then it would ask for that passphrase from that particular Avenger. And we'll set up unit tests around that to make sure it works correctly. We'll set up our unit tests so we can actually walk through and debug our code and see what's going on. So with that, let's go ahead and switch over to VS Code and we can get started. Okay, now that I've got VS Code loaded, I have my source directory, I have my test directory, which is basically the way I had it laid out on the slides. I have a virtual environment that I named dev just to show that I could name it something else. If you're not familiar with virtual environments, feel free to take a look at the previous episode 1, where we installed virtual environments. Not really going to be using any installation of packages, so it really won't affect what we're doing here today, although it's always a good idea just to set them up. So inside my source, I've got my common, I have my models, and I have my services. My common right now just has a simple utility for JSON to convert a string payload to JSON. I have a models directory, which I mentioned that we're going to basically create an Avenger model, which is right now just as a first name, last name, and the superhero name. And then I have my services. And the services will be the Jarvis AI security service. It's going to take a passphrase, or it's going to actually check the model and a passphrase to see if it's valid, I should say. So it's kind of like a login authentication sort of thing. And what it's going to do is it's going to grab the acceptable passphrases that I have right now. You could assume maybe it just would run this through some sort of AI or pattern recognition service for voice recognition in the future. But right now I'm just making it simple. It's basic text. It's in a dictionary format. It's expecting to kind of link up the superhero names to what their passphrase is. And so what we're going to do in here, we're going to get those passphrases, and we're going to see if that superhero name is in the passphrase. So as long as it's one of these, then it'll find it. And then it'll get that passphrase. So if it passes in Iron Man, it's going to get I am Iron Man. And as long as that passphrase that it returns from this list matches the one that they pass in, we're going to return true. Anything else, and we're going to return false. And that's just kind of basic authentication that we're doing for this. Okay, so now what we want to do is we want to be able to test this. And what you might do, you might put in a main function here that would run and actually test this, if you wanted to debug it. But a better way to do is just create a unit test around it, because then you can launch the debugger in the unit test and check to make sure that these things work. I've already set these up. So I've got my common, my models, and my test services. I also have this area called an init test, and I'm going to go over that in just a little bit. We'll start off with our common one. We just want to do a test of a payload against that. So we're going to start off small, keep it simple. And in here, I've got a payload. It's an API gateway payload. And when that API gateway would say send this up to, say, like a Lambda function, it's going to look like this. And we're going to go into a lot more detail in the next few lessons on this. But this is just basically all I really care about for this particular function is I want to get the body of the text, and I want to test that particular body and see if the file name will match this. So I want to basically parse this. I'm really just, what I'm doing is I'm parsing that string, and I want to make sure that it works, that my converter works just fine. So in order to run this, what we need to do is we can come over our unit test, and we need to set this up. This is a basic unit test. Should probably go over this really quick. I have a template that I put together that basically defines how a unit test is put together. I'm using the unit test module, and then you create a class. You can call this whatever you want. I usually align them with whatever file and service that I'm creating, so that way it shows up kind of nice and neat in this test area, which we'll see in a few minutes. And then you just pass in the unit test and test case. From there, you can kick off with a main function if you want as well. The unit test should find it without the main. This is if you want to kind of hit it directly. But actually executing with a unit test from here or the unit test command line should execute this just fine without this statement. So this is really the main thing that you need. You need your import, you need a class, and then you have to define a function, a test function. And then inside of that, you usually want to assert something, if something is true or false, or something equals something else, something is null or none or not none. There's a lot of things that we can do with this self-assert. So you could really do self-assert, and you can find all the assert options that are available. Check for a count to be something, if it's a dictionary that's equal to something. So a lot of things that you are built-in tests that you can just evaluate. If this evaluates to true, which this one does by default because I'm not breaking anything and it's just a template, the unit test will pass. If for some reason these do not equal each other, the unit test breaks, and you'll get that in your report. If you have this in, say, a CI/CD pipeline and your unit test fail, that should stop the pipeline from moving forward, which is what you want typically. There are ways around that in case you didn't, but ideally, if your unit tests are failing, that means something's broken. And you don't want to promote that to another environment, whether it's even dev, stage, prod, it doesn't matter. You really don't want, because you know that this is going to break something else within your system. Okay, so what we want to do, we're going to just start off simple, and we're going to make sure that this unit test can run. And so we need to start off with a few things. One is we need to tell the unit test what our pattern is to finding our unit test. And if we come back here again real quick, I'm just going to hide this really quickly. And I want, my unit tests are in a folder called test. So when I come over here and I say, let's go ahead and create and configure the Python test. And again, I'm using unit test here. We're going to configure it, and it's going to say, okay, what framework are you using? And we're going to say unit test because that's what we're using. That also supports PyTest out of the box here, but we're going to say unit test. And then it's going to ask, okay, where are the tests located? Are they at the root? Are they in, and these are two folders that I created. If you have more folders, it's going to list all of your folders. We know they're in the test. And so we'll say, okay, let's just put in test. And then it says, okay, what kind of pattern should I be looking for to execute test files? And I usually use this pattern right here where it's some sort of a name of my file, usually the name matching my other Python files that are in source, followed by an underscore test. Kind of gives me a one-to-one relationship of the files that I have in source to the ones that I'm testing. It's a nice, easy pattern to follow. So I'm going to select that. Now, it still doesn't see anything here. That's okay. But I want to show you what it just created. And it created in VS Code this settings JSON, if it's not already there. And then it added in some information on what the unit test does to find unit test cells. We have our V. These are basically saying what command line parameters are we passing into the Python test unit test module. V is for verbose, and then it's going to say a specific subdirectory, which was that test that we have. And then the parameter of what is it looking for, what types of files, and it's doing the *_test. So it should find, theoretically, any of mine that are under this test directory in any of these models, and anything in here as well, because in the services, because I have these as tests as well. So theoretically, it should see this, but it still doesn't. And the reason for that is that in order to, discover these tests from within the this testing framework, we actually need to have an init file in there. And that init file needs to just be inside these directories in order for them to kind of discover them. An init file was something that was really more popular in Python 2. You technically don't need them in modules in Python 3, but this unit test framework still requires them. So all you have to do is create an empty init file in here. I'm going to do an init.py, and there we go. So now, any luck? Yes. So we have more information over here, although it's broken, but it doesn't say that, it doesn't see anything. It doesn't look like it needs to actually be still initialized. It's saying, hey, I found something, but I'm kind of lost. I'm kind of confused. And what that is, and you can get more information here too. So this is something that you're probably going to experience quite a bit, and you should know how to troubleshoot it. So it says error discovering unit test, see output Python. You might be like, okay, where is my output Python? We can get to that if you open the terminal area, view terminal. I just did it with my command or control tilde. And then what it's referencing is this output. And you come here, and then you come to Python. Now, by default, it might be loading up something else. Who knows? It might be loading up all sorts of stuff. So just come over here, and if it doesn't have output in Python selected, just come to Python. And here's where we're going to get that module not found error, okay? And it's saying, I don't know what common is. And the reason it doesn't know what common is because based on the paths that we're using and based off of what it knows about, this area for the unit test really only knows about the path of the root of this directory and the test of this directory. So it doesn't know about the source. One way we can kind of fix this in an ad hoc way is we can do source like this. And then that should change it to here. Now, this is actually going to cause more problems than we want down the road. And I'm going to come back to that in a few minutes. So what we want to do is we actually want to fix it. We just really want to tell our unit test about this path. We want it to make sure that it understands what the path is. And a way we can visualize that is if I were to just put some code in here. I'm just going to actually just add in a couple imports, and then I'm going to just have these where I can copy and paste them so quick so I don't fat finger anything. Type slowly. All right, so what this is going to run, and what I really want to see, I want to make sure that we see what this path is right now. And let's come over here. We can come over here and we can say, let's go ahead and debug this unit test. And it's telling us what the path is. And as you can see, the path has some information. It has test, and it has the root, and it's got some other framework things going on in here. But what we really need to do is have source in here so we can reference this like this, and it knows about source. Now, VS Code seems to know about it, but when we execute the test library, it does not, because it doesn't know about the path. It's just not there. And Python is a very path-oriented sort of system and execution. So in order to do that, really simple. We can just put in this information here, which would add in a path. So we're going to see what it's like beforehand. We're going to see what it's like afterwards. Still going to get that error because it doesn't know about it yet. Because even though I'm putting it in afterwards. I just want to show this really quick. Oops. Okay, so we're going to come back in here. We're going to debug this. And then it's going to say, okay, that's the path. What we have in there. So still no source in there yet. But if we say, let's get the current working directory. Great, we'll do that. Let's append source to that, and we're going to insert that into the path. And I'm just going to insert it at the top of the path. It doesn't really matter where it is as long as it's in the path itself. And then pass it in. And now if we do this, we should see that, okay, cool, we have our source, right? This still won't work if I remove this, just because it's going to try to load this first before executing this. So this is going to run fine because I do have source, but I just want to show you really quick. We're going to step into that function in just a few moments. Okay, so let's do this. I'm going to just show you that this is still going to break here. I'm going to get that error here. We're going to see that error over here. But now if I just simply move this to the top, and Let's see, let's just put it like this. We're going to actually move this just below it. There we go. And I guess we can just leave this in for now. We'll clean this up in just a moment. Once I save this, we're going to see that this magically is going to work over here. This should come over here as well. So let's save, discovers. Hey, everything looks good. We're not getting any errors. We see it over here. So we're good to go. So what it's doing now is it's going to go ahead and insert that path here. And then by the time it gets to this point, that path is already going to be loaded into memory. And now it can actually find this. It can map to that. So let's go ahead and we're going to debug this and walk through it and see what it does. Okay, so now we're in here. We didn't get an error, so everything loaded fine. We have our path in here, which means it can find it this way, which is awesome, which is what we want. And then we can now start stepping into this function. It's getting executed for us. We're getting this payload down here, which I just separated into another function, mainly just because it's big, it's ugly, and I didn't want it to muddy up this particular unit test. So if I just step over that, all it's doing is it's loading up that file as the way we would see it from like API Gateway. And there's the body, which is basically a string that we want to convert to a JSON payload. And we're going to get that. Then this is where we're actually going to test our function. So we're going to pass in that body. And we're going to basically just run the internal JSON load string. And we're going to step out. And now we're going to be expecting that inside that JSON package, we should have file name, and we are expecting that to be there based off of what we have in our payload down here. So it's really just doing two things. It is testing that this function works, and it is testing an expected value that this function should load based off of the API Gateway payload. And if we come down here, the file name should equal each other. And as long as it runs fine, we don't get any errors. We get a green light over here that everything worked great. So now we've linked up one of our unit tests. We just now need to link up the other ones as well. So in order for it to find any of these others, each one of these needs to have an init file in it. Okay. So if we come back, right over here in our testing, so we only see the one, and we want to see all of them. So all we need to really do is copy and paste this empty init file into each one. If we come over here, now a funny thing happened is because it already loaded one of these files, it literally understood and knew about the paths. So if we run this now, see if everything runs clean, clean here. We can also just run all of them from the top. Now that can get a little bit confusing at some point if you start adding more paths or anything like that. So ideally, one thing you want to do is you can take this out of here. I'm just going to show you what happens if I get rid of this. Oops. What am I doing here? Let me get rid of this. I'm just going to put these in here. So again, if I take this, and if I move it out, I'm going to get those errors. In fact, none of them are going to work now. So if we look over here, we're going to get an error here. Should get an error here as well. Yep. So as soon as I save it, we're getting errors all over the place. So ideally, you want to have it in a central place that makes it easy to modify. You also don't want to, kind of muck up your unit test with a bunch of source. One place you can do it, if you just have one unit test, you can do it in here in this particular, any one of the inits. Right? It's so weird that you only have to have it in one, and then it finds everything. So if I run these, everything looks good. I like to actually just create a top level init test. In there, I'll often put a template one that's going on, and then I'll also add that init file here. And I already had one. I just had it kind of named funny just to kind of hide it. So I'm going to put that here, and that should take care of it for all of them. So I'll get rid of this. And because I have it in just one of these directories that matches kind of the same level of these other ones, then it's going to find it. It's going to load this first, and then it's going to see everything. And if I set a breakpoint inside of this one, again, this is in this init test area. And let's say I want to debug the same one that we did a moment ago. So we're going to come back to this one. We're going to debug this. We're going to set up, okay, cool. We got a breakpoint in here, which is good. Not going to worry about breaking here. We want to break at this print, but we also have a breakpoint set in this init here. And so we're going to see that we're actually going to hit this section first when we run a test. And then what we're doing now is we're going to grab the current working directory. We're going to add the source to the path. I'm just going to print this out if we want. And then we notice that our unit test loads and everything's going to load fine. And then that's all there is to it. The other unit tests are there as well. I have a model test that just loads in the model, the Avenger model. It sees our models. Then I have, my Tony Stark. I'm testing for Iron Man. I'm just testing one model just to make sure that the values are equal. It's a pretty basic test. And I have my services test over here, and that's the one that's a little more fun. I'm creating an Avenger. I'm saying what the superhero name is. In this case, we have the Jarvis security with the passphrase of I am Iron Man set to result to true. I have one with Thor thinking he's the strongest Avenger, and in my test, in my security model, Tony doesn't think he's the strongest Avenger. In fact, he thinks he looks more like Patrick Swayze from Point Break. So that's where I came up with the Point Break. So that will this will fail for him acting as the strongest Avenger. It will authenticate him if he says Point Break. And so we can see those in action if we just set some breakpoints here if we want. And then we can set a breakpoint here. And we'll go ahead and debug this as well. Here. Wrong thing. We'll just go ahead and run all of them. I can run each one individually. I can run them all. I'm going to run them all. I have 2 breakpoints set in here. I have them just on these 2, so it won't break here. So let's go ahead and run all of these. Oops, I don't need this anymore. So we have the Avenger for Thor, where it's supposed to be Point Break, and that one should be true. So we load up the Avenger. The Avenger has some information in it. I only didn't worry about populating first name, last name, just the superhero name, because that's all that I need for the security passphrase test. It's loading up the object here. Now we're actually passing in the Avenger. We're passing in the passphrase that is Point Break, sorry. Here is where I get my list, which is what's down here, which again, think of this if it would have been a database, or maybe you'd pass this off to an AI recognition system if this was actually a vocal phrase coming in, but right now it's just text-based. So the superhero is the superhero name inside of this passphrase, and it's going to look for these keys. It's going to find it. And so now it's going to grab from this passphrase, from the superhero name, what its passphrase should be. So it should be coming back as Thor, as Point Break. So that is what we are loading in here, Point Break. And then what was the passphrase passed in was Point Break. So this should evaluate to true. The result should be true, and we are expecting true. Excellent. Now the next one with Thor, strongest Avenger. When he tries to pass in that he is the strongest Avenger, again, I've got the Avenger here, Thor, same sort of thing. He thinks he's the strongest Avenger as his passphrase. We're going to go in here, get those passphrases again. Same thing is happening. It's just going to load those up from here. It's going to say, is the superhero name in the passphrases? Yes, Thor is in there. Now we're going to get the passphrase that's stored in those passphrases. His passphrase is, of course, Point Break, but he thinks his passphrase is strongest Avenger. So that's going to return false. And it should say false here. And we are expecting false. So that's why this is passing our unit test. If at some point in the future, somebody messed around with this and thought that this should be true, this will break this particular unit test. Okay. And what that would look like is we can just run this if we want really quickly. It's going to break. It's going to say, false is not true. That's the assertion error. So that's why we would get an error. This would break our unit test, break our build, and then you want to come in and fix it after the fact. And what that looks like if you want to just, kind of debug it really quick. Again, all we're doing here is we're just asserting that it is true when it should be false. Not going to worry about this one. So we're going to come in here. Thor thinks he's strongest Avenger. Somebody changed this saying, oh, that's going to be the appropriate one. Passphrase. Again, it was in the passphrases. It's supposed to be Point Break. He said strongest Avenger. We're returning false. Still false. Set to true, which is great. That's what we want. And that's what breaks here. So we know that this should be false. This should work now. Now, on the flip side of that, let's say, our unit tests haven't changed, but somebody broke into the system and somehow made Thor the strongest Avenger as well. So this is just kind of like maybe somehow some logic got changed. This is just an example of that. So now Thor is showing up as strongest Avenger with inside the system, and we're expecting it to be Point Break. So when we run this one, it's going to fail because it's expecting it to be false. And when we run Point Break, this one's going to fail as well because we're expecting it to be strongest Avenger. So this is a way that you can always test your code. Your unit tests are designed so that they run through and they have an expected result. And whether that's here as a hard-coded value or numeric calculations, whatever it may be, unpacking a payload. This way you can feel that any changes you make to your code, won't hit production if they are inaccurate, because you run them through unit tests. If they pass your unit test, they should be good to go into production. If they fail your unit test, then you need to look at what failed and fix that before pushing it out to production. You don't want to come in here and just change your unit test to work correctly, because that still means the logic is bad. You want to look at the underlying code and see what happens. Now, sometimes that might mean that you do need to change the underlying unit test as well, if the logic changed, meaning the unit test needs to change as well. But most of the time it's you broke the code somewhere along the lines, and your unit tests are now failing because of that. So it can give you that confidence, especially if you're refactoring a lot of code, that your unit test should still perform and function the same way that they did before and after the refactoring, because you're really only concerned about that output or what that function did do, not necessarily how it did it. So now we know that somebody got in the system or they changed something, they broke it. We go look and say, oh yeah, somebody was just messing around, or maybe Thor broke into the system somehow and he changed that, and we need to get that back. Otherwise, it's going to break a lot of other systems where he's going to get access to things he shouldn't. So now we change it back. That works, and that works. One last thing I want to go over is what I mentioned earlier about that source path. So let's say that we come back into here, and let's say we don't add the source path here, which means that our unit tests are going to fail the discovery pattern. Okay. And again, for that output here, for that output, it's telling us what's going on, which is pretty nice. It's going to say, okay, inside of the security test, it can't find the modules. If we come in here, it's going to say, oh, it can't find that. So we know, oh, if we do this, again, this is going to be a bad habit to do. And I'm going to show you why in just a second. And then I'm going to do this. And now it's going to say, okay, that works, but we're going to have a problem with the actual underlying service. So it's referring not to this anymore, but to the underlying service that's in my source. So if I were to go into this one, I could say, oh, okay, well, in order to fix that, because again, the test is following that certain path and pattern. It only knows about the root, and it only knows about test as far as the directory structure. So in order for the test now to see this, we'd also have to put source here. Now it's going to see it. The other ones are still going to fail because they're going to have the same problem. So you might think, oh, okay, I can run these now. Everything works. But you have to think about this when you deploy it into the wild. When you deploy it into a production environment or even a dev environment, this path is no longer going to be valid. Typically, when you package up your Python code and you deploy it, you're not including this source directory. You're including everything underneath the source directory or any of the libraries that you need specifically for that function to work, but you're not including it in the source. So as soon as you throw it up into the wild, and then this starts referencing things from a source, up in production or wherever that might be, even a dev environment, you're going to start getting errors of module not found because source is not going to be there. That's why you really want to make it work for how your models are going to work with inside source directory and mimic that in your test. And again, just to do that, we're going to remove that source here. We're going to go back into our test. We're going to get it out of here and out of here. And then we're going to go to that central location where we kind of set up those paths. And we're going to add it back here. Now everything should be looking good again. All right, that wraps up episode 2. Thanks for watching. We did our Python directory structure and our unit test. So we got to see what some standard directory structures are, how to set up a unit test, how to troubleshoot those unit tests when they don't quite get set up and initialized correctly. Took a look at the module not found error, which will happen, with unit test or with just setting up references to other pieces of parts of your project with modules. And then we also got a chance to debug our unit test. So going forward now, taking this to the next level, we have some kind of base competencies going here. So let's take a look at now. Let's get this up into the AWS infrastructure and into a Lambda function. That'll be what we're going to focus on next. We're going to take a look at AWS Lambda. We're also going to look at the Lambda or the AWS CLI for that matter, and the AWS SAM CLI. It's going to allow us to debug and test an AWS Lambda function before we even deploy it. Once we get that down, we'll take a look at then also setting up a CI/CD process so we can automate our deployment of our functions. We'll look at automating our unit tests as well. So as we deploy it, CI/CD pipeline will run unit tests as long as they pass, then it'll deploy it. We'll take a look at other features as well as far as like security. We'll take a look at maybe Cognito, take a look at integrating with DynamoDB, perhaps even step functions. I do want to make a lot of this driven by you. So if you have some ideas on how you want to, or something that you want to learn, how you want to execute it, drop it in the comments. Let me know. We'll see if we can incorporate it into the upcoming lessons. But with that, again, thanks for watching. If you would, like and subscribe, it lets me know that people are actually interested in this, and then I will spend a lot of extra time producing this content. So thanks, and I'll see you next time.